Okay, so our domain is just the x values, where they start and where they stop. So it looks like what x's can I put into here, right? I can put in a -1, I'll get out this y value here. I can put in a -2, I'll get this y value. I can put in -3, I can put in -4, but oh crud, when I try to put in like a -5, there's no graph over here. Oh no. So the smallest x value that I'm allowed to plug in is this -4, because I can count -4 here. 1, 2, 3, 4. That's the smallest y value. And then I have no problems putting in y's up until here, or x's up until here. So 1, 2, 3, 4, 5. So it looks like my domain is from -4 to 5. And I put the brackets on it because I can equal 5. X can be 5, I get a value there. And x can be -4, I get a value there. So from the starting x to the final x, the starting x to the final x, that's what this notation means, starting x to final x. And it's again kind of annoying because it almost looks like ordered pair forms. In fact, if I weren't allowed to equal the -4 and the 5, it would look like an ordered pair, which messes students up because it doesn't represent the point -4, 5. It means something different in this context, that interval range. Interval range. And then now we're going to do the range, and the range are the y values, and the y values are so what y values can I get out of this function? And I'm looking like up here there's no y, right? So the tallest y I have is here, that looks like 4, and the smallest is down here, that's 1, 2, 3, 4, -4. So from bottom to top, my y's are ranging from -4 to 4. -4 to 4. And that's my range. It's increasing, so I can tell my function's going up and then down and then up and then down. And so when they ask for increasing, they're asking for the x values. So I can tell that my function is going up when the x's are between -4 and -2. So from -4 to -2, and I'll use parentheses here because at -2, like, I don't know, is it increasing or decreasing? It's kind of stopped. So I'll use parentheses there. And again, it's not an ordered pair, it's x start to x stop. And now I'll go to decreasing here because I'll just ride the graph. So from -2 to x is -1, I'm going down. So for the x's that are between -2 and -1, it's going down. Then from -1 all the way up until when x is 4. So from -2 to 4, it's increasing, and from 4 to 5, it's back to decreasing. There we go. The last thing they ask is if it's 1 to 1. So we learned a vertical line test a long time ago. So this just means like there's one x for every y, and 1 y for every x. So 1 to 1, 1 x for every y, 1 y for every x. And this 1 y for every x is the idea of just being a function, right? So when I put in a 2, I only get out that 1 y value. When I put in a 3, I only get that y value. So this guy here is passing our vertical line test. He's certainly a function. But whether he's 1 to 1, he has to pass a horizontal line test, and oh no, 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 he fails, right? He's failing here and he's failing up here. When y is negative, let's do the one up here. When y is like 3, I'm getting 2 possible x values that go along with that. So it's not going to be 1 to 1. And not going to be 1 to 1. So to be 1 to 1, you have to pass both the horizontal and the vertical line test. Any horizontal line can't pass the function twice, otherwise it fails.